get to share a space, see all of the vendors, all the people who really bring the product to life. It's really special to just be in a space where we get to gather together from all over the country.
I'd now like to announce this year's winner of the ADI Distillery of the Year Award.
Their conferences, their classes that they give, they're great if you're really serious about learning how to do something correct.
Signature Serve Invitational, which is a cocktail competition that we put together to pair craft distillers with some of the best bartenders.
Awesome, and their cocktail is awesome. Go Leo! Woohoo!
Hello, everyone. My name is Eric Owens. I am the president of the American Distilling Institute. I am honored to be hosting you for this webinar on rum. The first thing I wanted to announce was we have our show in Miami coming up in August. We are the oldest and largest professional association of craft distillers, and for 23 years we have been running the ADI conference, and we would love to see you all there. We have an education expo if you're a brewer, a winery, a brand owner, or distillery employee, or a spirits industry professional. I think there's something for all of you at our show. As part of the show, we like to run summits to highlight different spirits. Being as we are in Florida this year, we will be running a rum summit. We'll also have a gin summit. But yeah, really, rum and Florida seem to go together really well. And as part of that show, we will be presenting some research. Well, one of the hosts, maybe both, will be presenting on yeast. And so for me personally, it was as part of one of the original rum summits we did was Johnny Verplank brought up rum fire. And I had no idea what that even was. And so I went out and spent my $28 and got the bottle delivered to my house and opened it up. And I was just absolutely blown away. Couldn't figure out what's going on with the nose, couldn't figure out what's going on with the spirit, and really just fell head over heels in love with rum. And just, the more I sort of dig into it, the more I learn, the more I know that I don't really know anything. And so you can read about these processes and learn about them, but really it's that experience of tasting spirits and then finding out more, and then tasting spirits and finding out more. And so, yeah, I really am, I'd really love to find out more about it today, which will be the Cousins process and making cane acids. So I invited John Hayes and Brett Stiegerwaldt onto this webinar to talk about how that is done. John and Brett will be doing presentations. If you guys can chat, but if you have any questions, we'd ask you to hold those to the end. We will have a Q&A at the end of this webinar. And with that, here is Brett and John.
Hi, everyone.
How is everybody doing? Really excited for this. Right. Hello, everybody, and welcome to our presentation, Bringing the Funk, the Cousins process and how to make cane acid. Sorry, having a little trouble. This is our agenda for today. We're going to have brief introductions of ourselves, And then we're going to deep dive into the historic Jamaican rum production techniques, covering cane acid, dunder, muck, and the Cousins process. We're then going to jump over to Puerto Rico and talk about Arroyo's heavy rum production techniques. And then John is going to take it away with modern explorations of Jamaican and Arroyo techniques. And then I will cover applications for other spirit categories, and we will conclude and field your questions. And that will also contain our contact information for follow-up questions, because I'm sure there will be many. So this is me, Brett Stiegerwaldt. I'm the head distiller for Lion Rum. So in the upper right-hand corner, that is Lion Rum, located in beautiful St. Michael's, Maryland, just pretty close to Baltimore and D.C. on the U.S. East Coast. I'm also the consulting distiller for Rosalie Bay Distillery in Dominica, that is north of Martinique, south of Guadeloupe. That is the bottom right-hand image. We are the world's first 100% nonprofit rum distillery, where 100% of the proceeds and revenue go back into community efforts, as well as ocean conservation. So think like sea turtles. There's 3 different types on the island, as well as coral restoration and a bunch of other wonderful work on the island of Dominica. We source from 65 small farms, and it's all hand-cut sugarcane, crushed, fermented, and distilled on site. Bottom right-hand image is of Jacob Levinson, the principal behind the Rosalie Bay, as well as Mr. Charles Waddy. And that is us in the cane field very early on in the project. And I had the privilege of being a 2025 ADI Distilling Research Grant recipient. And for those of you attending the conference and the Rum Summit in Miami, you will get to hear all about the cool stuff we got to do this year. Now I'm going to pass it over to John.
Hello, everyone. I'm John Hayes. I'm the head distiller at Cotton and Reed Distillery in Washington, D.C. We are D.C.'s first rum distillery. We produce only rum, so everything that we have is rum-based and rum-adjacent, that is produced from our own spirit. A little bit about me. I have a Master's of Science in Organic Chemistry, which kind of led to a lot of the research projects that I've been doing for the ADI Distilling Research Grant. And that's really opened the doors for what we're going to be talking about today and potentially at the ADI conference in August. So I'll pass it back over to Brett for the background, and then I'll come back to you later to tell you about what I've been doing.
Pretty cool science, that's for certain. All right, so we'll just bring it back. Right now it's 2026. Let's go back a bit in time to rum production techniques from 1890 to 1920. So at this time, both in Jamaica and across the Caribbean, they were starting to have a better idea of what was actually going on in the fermentation environments. And this led to 2 big divides in the research community, which honestly you still see today. Perot was advocating for pure fermentations using selected yeast and a low bacterial presence. So if that sounds familiar, that means cultured yeast. That means a somewhat sterile-ish fermentation with low bacteria, and that would allow you to develop a softer, more neutral, easy drinking kind of rum that's very consistent and easy to produce. In Jamaica, Allen and Ashby were highly advocating for bacteria because they felt that bacteria plays a major role in the organoleptic qualities of heavy rum production, particularly in Jamaica and elsewhere in the Caribbean. Now, at the time in Jamaica, they were finding lots of Saccharomyces strains in what is called common clean rum fermentations. And I'll cover what that is shortly in this presentation. So think of that kind of as your more modern style approach. If you use, say, EC 1118 or any of these other more modern rum strains that kind of have a neutral profile, we're pretty familiar with common clean rum. It's, lower ester profile, softer, not too funky. Now, on the contrary to that is those rums that would be produced from Schizosaccharomyces or fission yeast. Those were primarily found at those estates that were producing high ester marks, so very funky bacterial, forward products. And although they were found all the way throughout Jamaica, they tended to be concentrated in the northern sugar estates. So right now, the 2 that remain on the island would be Hamden and Long Pond. And for those rum lovers listening right now, you're very familiar with the beautiful high ester marks of both of those facilities. Now, as they really did in investigations into the bacteria that played a role in this, those that were found produced large amounts of acetic acid, lactic acid, and butyric. And before I move on from this slide, I just was looking over here at my notes. I just want to say one thing. I'm going to be covering a bunch of information today that I was able to find on Google Books, and I am more than happy to share that with you. So definitely reach out after the presentation. It'll save you a few hours of your life trying to find this material. But as you read that material, you'll find that the discussions that they're having in that time period, so 1890s, 1920s, are still highly relevant to today. So one of the big takeaways that I would love for you to have from this presentation is please approach the world after this with a sense of openness. So as you learn stuff, do share it with the distilling community, particularly on the rum side. So together we can all make better rum and be able to leverage these really fun techniques to make great rum all over the world. And the one other thing that was advocated highly at this time was slow fermentations. That was the key to allowing the time for the bacteria and the yeast to do their thing in the fermentation environment and to allow the production of these higher ester marks. So we'll just dive right into this. Allen in 1906 and Ashby discussed cane acid in the literature. And for most of us, when we hear cane acid, oh, you just thought probably sugarcane juice fermented. It had some kind of aerobic bacteria, acetobacter going on, converting the alcohol into acetic acid. Yes and no. Yes, that definitely happens, but it was more than that. And again, at the time, you have to contextualize this, is they weren't necessarily using culture D strains or culture bacteria or anything like that. They were leveraging whatever materials were on the island to kind of hedge their bet that they would get acetic acid or lactic acid or these other acids in their fermentation environments. And this process is the way that they did that for cane acid. So as you can see here, you had fermenting sugarcane juice from dunder from the still. So that's going to be it's going to be acidic. It's going to have dead yeast cells. So there's going to be nutrients there as well as skimming. So this would be like a Jamaica train setup of like 5 or 6 sugar pans in a row, and they'd be using a spoon to take off the skimmings, and then that would occasionally be added. So the goal here is to make a fermentation that would, of course, be sugarcane based and yield an alcohol product, but then it would be deliberately moved through what are called trash cisterns, which is where it would pick up the acetobacter and the other bacteria that were present. So as you can see on the slide, as it would work through each one of those trash cisterns, the acidity of that would go up significantly. And occasionally they would have to add yeast sludge from the wash, so that would be dead yeast cells rich in nitrogen and other nutrients to feed those. And at the end of that process, you would then have cane acid that would be ready for use in your fermentation process. Now, the trash cistern is a cistern or just a tank. Cistern was the word at that time. That would contain leaves, stalks, and just other cane material. And so if any of you have ever been in the Caribbean, you know that as soon as you crush cane juice, it will very quickly start fermenting because it's very rich in bacteria and not nutrients, but yeast on the outside of the cane stalk. So they were leveraging this for each one of those cisterns. And they would say that you knew the cane acid was ready in each one of those cisterns or at the end of the process when it started to smell like really good sour beer. Now, Gregg in 1895 commented that occasionally some estates would have trash cisterns that they would manage and keep alive, kind of like, think of it like a sourdough mother. And they were just trying to ensure that it had just enough acidity, just enough nutrients that they could continue to use it all year long. And the one thing that he mentioned at the time was that those estates that did this generally didn't see a lot of high-priced rum being produced. And by that, he means like the high-ester marks. And they would feed it with dunder and molasses to do that. And instead of it just being only acetic acid that you would get, you would also have some amounts of lactic as well as butyric, because they didn't really have an ability to control that much that was happening in the trash cistern process. So just to give you an example, this is what a modern cane acid pit looks like in our time. So this is taken from Matt Petrick in 2023 during his visit to Jamaica. I believe this is Hamden, or it could be Long Pond. But as you can see here, you've got a pellicle on the top. You've got cane trash just sitting on there, just yielding rich amounts of bacteria into that environment. And if you look around, you can clearly tell that it is not sterile. So you've got a lot happening in this, producing large amounts of acid in this liquid. Now, As they started to develop a better understanding of the whole process, again, Allen and Ashby really started to try to understand what was going on in dunder. And for most of us, we know dunder is the spent wash, after the stripping run. And that is rich in, you've got a liquid and solid portion there. The solid portions tend to be your dead yeast cells and other things that would precipitate out in your fermentation environment. And then you have a liquid portion. So the solid portion at that time was known as dunder muck. They would let everything stratify, everything precipitate out. They'd rack off the liquid portion and use that when they're setting their wash, because it contained large amounts of soluble material, and it tended to be a nutrient source for the yeast and the bacteria, of the subsequent wash. The dead yeast that were left over in the still was then pushed over to the muck making process, and I'll cover that shortly, because it's very rich in nitrogen and other minerals that would be needed for that step. At the bottom of the slide here, you can see Ashby took time to kind of better understand what was going on in terms of dunder composition across the various estates that he visited. And one of the things that he makes mention of, it always contains some amount of volatile acid. There's no way to get rid of that. And you can see that the Brix levels were quite varied, and it really depended on their ability to have successful ferments, as well as the bacterial presence and everything else, because some of these, as you'll see later, had very high gravity fermentations, and your Brix levels varied dramatically, anywhere from less than 10 to 25. Sugar concentrations varied, and as well as glycerin tended to be around 1%. Now, they don't state in the literature whether that's by weight or by volume or some other comparative metric, so this is the best that we have at this time. This is a dunder pit, and as you can see, just like in the cane acid, it is not a sterile environment. This is a cement-lined tank, so cement is a porous material. So as you have successive dunder going into this, not only are you you're feeding it because you're getting successive rounds of new dead yeast cells and other things, but you're getting bacteria that are going to exist in those walls of this tank, such that you're going to have large quantities of lactobacillus developing over time in these pits. This is the muck flavor process that Allen documented back in 1906. So kind of like the cane acid case, you see here that they're, again, leveraging these trash cisterns to yield large amounts of bacteria in this liquid before it gets used for later on in fermentation. And the way they did that was you'd have fermenting cane juice, cane trash, mature dunder. So think of that really acidic dunder that's rich in large colonies of lactobacillus, as well as liquid from what they called the muck hole. And they didn't really define it in the literature, but that's the little box at the bottom here, on the bottom right here, is what they did state. So they used the dunder muck, so the dead, the solid portion of the yeast that was left over from the stripping run, as well as retort lees. So that would be the liquid that was left in either the high or the low wines retorts in the distillation part of the process, cane trash, as well as, and I quote, miscellaneous organic material that enters the tank from time to time. It didn't seem like the lids were that secure, or it could have been open to atmosphere, so you never know who or what got in there, which is why you have legends today of like dead animals or lizards or whatever. But you can see here that, again, they're leveraging the cane trash in that muck hole for the bacteria and yeast that are present there. The dunder muck is your nitrogen source. Your retort lees are a source of alcohol, as well as large amounts of acids. And then again, the miscellaneous bacteria. So again, if it's exposed to oxygen, you're going to have aerobic activities happening, anaerobic activities happening after a certain time. And you're going to develop something that's going to be really funky and nasty, but rich in bacteria. So again, they combine all of these into a cistern or tank outside the fermenting house. And then once everything's mixed up and ready, they then will go through the trash cisterns, the second and the third. So they're targeting a certain level of acidity by going into that second trash cistern. And as you can see, they're also feeding these during this process, because they're trying to cultivate this over time to be a liquid that's very rich in butyric and other higher acids that would be later leveraged during the fermentation process. This is an image of a dunder tank, a muck tank. And I'm going to quote my friend Matt here when he said it smelled god awful. So if you've ever had butyric acid at all in your facility, you know, it can smell like vomit. It can smell like a lot of things. It is not a fun smelling thing, but once it esterifies, it's beautiful. So if you're going to undertake this, just you may want to warn the neighbors or do it in a place in your facility where you can handle that smell. Now, before we get to the fermentation regimes that led to all these different styles of Jamaican rum, it makes sense to kind of cover what was being produced at the time. So between 1890 and 1920, you had 4 different styles that were being made on Jamaica. You had the standard common clean, and that was produced by every facility on the island, and it's kind of what paid a lot of the bills. It was rum for the for the domestic consumption on the island, not super heavy, very light. Principal aromas of ethyl acetate, trace amounts of higher acids. So very standard, kind of just everyday, easy drinking unaged rum. Between 90 to 300 grams hectoliter of absolute alcohol. UK home trade was a slower fermentation that was able to produce that. Medium bodied, mainly higher esters of higher molecular weight acids originating from the bacteria. So again, here at this point, they're starting to leverage those bacterial ferments to provide acids for later esterification. And if you look between the UK home trade and the tea rum, you see that you've kind of got an ester range of 300 to 700 there. So if you've ever had a Smith & Cross or any of the Plummer and Wedderburn styles or any of the beautiful independent bottling releases of Jamaican rum that showcase the medium-bodied style, you can see how versatile it is. Now, they don't really make tea rum nowadays anymore, but it was kind of rum that you would have with afternoon tea, maybe a spoonful into your tea and have these fruity tropical flavors. Cold winter's day in England or the United Kingdom at the time, that kind of sounds pretty nice, right? And then the flavored or the German style rum at the bottom, you can clearly tell it's much higher in esters and much longer fermentations. And you're utilizing fission yeast, so Schistosaccharomyces pombe, and these would be primarily used as a blending tool. Now, occasionally you would have these being released because at the time, the higher the ester amount, the more expensive the rum was. So facilities did try to make these as part of that. And as you see, as we walk through these different fermentation process diagrams, what happened because of this? Because, you know, if you're, many of us have small facilities, we only have so much space, so many tanks available. So once you dedicate a tank for dunder for the season, you've got to manage that, and you don't want it getting too acidic, for example. So this is an example of the lower ester version of a common clean rum. And if you take away the skimmings, it looks pretty much very similar to a modern distillery approach to, making rum. So the skimmings would be just the skimmings from the Jamaica train. It'd be you'd have bubbles that would be forming during the caramelization of the sugar, and they would skim that off. You'd have dunder from prior distillation runs. So think it's going to have acids, sugars, and nitrogen. You're obviously going to have molasses, and then here you're using water as your dilution to target your wash setting. In this case, they are targeting 16 bricks. And for those of you that may not use bricks, this is around 1065 for specific gravity. Fermentation will be complete when it's around 3 to 4 bricks, or 1.012 to 1.016. And in general, this would be the rum for the home market on the island. This would be probably the rum that paid the bills for most of the facilities. And it was not a high ester mark. So this is version 1 of Common Clean. The second version, and notice you've added acid now, is where things start to get really interesting. So you still have the skimmings, dunder, molasses, and the water as part of your process, but with the cane vinegar coming in, you're now adding acetic acid and small amounts of lactic and butyric from that cane acid step that we showed previously. You're getting lactic acid and lactic acid producing bacteria from the dunder, as well as sugars and nitrogen, especially if over the season, as that dunder would mature and you'd have more and more, richer colonies of lactobacillus here. And here you see that the gravity is much higher. Your starting gravity in this case is going to be 1074 to 1.101, or 18 to 24 bricks. Unfortunately, in the literature, they did not state the ending gravity, so we don't quite know where it bottomed out. We do know that the fermentation time was longer, a little bit, 5 to 9 days, and they were very adamant about a 2 to 3 rest day period. And this would produce a common clean rum that had about 1,000 grams per hectoliter of absolute alcohol of ester content. So it's very potent stuff that was produced from this fermentation profile. Now, again, two things here to take away is it entirely depended on the amount of acids that were produced during the fermentation. So you wanted to make sure that your cane vinegar was rich in what those colonies that you were looking for, as well as the dunder, which over time and over the distilling season would get richer and richer in those colonies of lactobacillus. Additionally, they were very adamant at this time about letting the fermentation rest once it is considered dead or non-active, to allow every smaller activity and reaction inside to happen fully before you process it. They were very adamant. They said if you rush that, you're not going to be able to produce a quality distillate. And finally, the flavored and or German style rum. Now, I keep referring to German style rum. Why? Well, at the time, Germany had a very high tariff wall up, so it made it very hard for spirits outside of Germany to get into the country. And in order for Jamaica to get their products over there, they had to dramatically increase the ester content so they could use it as a blending tool to combat what was being produced and still produced now called rum verschnitt, which was a rum-like product but wasn't rum, that was made from local brandy or produced from, say, beet sugar, and then they would blend in other things to make it kind of like simulated like a rum. But this process allowed them to send over authentic Jamaican rum and then be able to create authentic Jamaican rum blends in Germany. Now, as you see here, it's quite a complex fermentation. So you've built off that common clean version 2 that I just showed you, and now that you've added muck. So now we have the full trifecta. You've got your acid, you've got cane acid, you've got your dunder, and you've got your muck. So you're getting acetic acid at least, you're getting lactobacillus, and you're getting butyric, and a whole host of other bacteria that are quite present in the fermentation. And again, notice you've got a very high starting gravity, or Brix, 25 or 1.106. Your ending gravity is 12 Brix, so 1.048 for specific gravity. So you can see that they're leaving a lot of sugars behind because of that. And the literature didn't state why they chose such a high gravity, so we can only speculate from there. And then notice that the fermentation time is at a minimum 9 to 10 days. Many estates went longer. And then after that fermentation completed, they had a 3 to 4 day rest period. And again, sometimes some facilities went even longer because they wanted those late bacterial actions or some other, especially if they're open top fermenters, things coming in on the wind, so to speak. Now, again, these were all natural fermentations. They weren't pitching yeast. They weren't doing this. But what they noticed over time was you'd have Saccharomyces cerevisiae active at the very beginning before acidity got too much. And then once the acid levels got very high, you would then principally have Schizosaccharomyces active for the remainder. And this type of fermentation would produce ester levels up to 1,600 grams per hectoliter of absolute alcohol. But you are sacrificing a large amount of yield for flavor. So the prior one that I showed you ended up yielding about 60 to 90 gallons of rum at 80% for every 1,000 gallons of wash. This fermentation would give you about 48 gallons at 80% for every 1,000 gallons of wash. So it is much less. Now, Allen, at the time in 1905, thought that this was a very overly complicated and crude attempt to foster specific strains of bacteria for acid development. And this is ultimately what ended up leading to what I'll be describing right after this is called the Cousins process, where he figured out how to leverage these acids from the retorts to make high-ester rum on demand at any estate. So as you can see, it's quite an in-depth process. And one of the things I want to say at the beginning is, in the literature, it says solid lime salts. And from a cursory background search, I know that there were calcium caprolate and calcium caprate in there, but there were definitely much more than just those listed in that little box. So just think of lime salts, which then get liberated through that sulfuric acid step. And John's going to go much more into this in his section coming up shortly. But so Cousins figured out, these estates that are making these highly flavored rums, again, only have so much tank space. So if they're leveraging their dunder throughout the year, it's getting more and more and more acidic and hostile to their standard common clean rum process. So ultimately, this process was created so that facilities could make high-ester rum on demand and not sacrifice their ability to make common clean rum throughout the year. And the cool thing about this process is instead of him being limited to say 1,000, 1,600 grams per hectoliter of absolute alcohol, he could create marks up to 4,000, 6,000, or even higher. So basically he's making a rum concentrate. And again, his whole purpose was to help Jamaica combat this rum verschnitt product that was being made at Germany at the time. So they could send over this rum concentrate, and then they could use it very small amounts in blends to make authentic Jamaican blended rum products in Germany at the time. And ironically, the backlash from this process grew significantly. And by 1935, Jamaica had to codify a maximum of 1,600 grams per hectoliter of absolute alcohol as their maximum ester content, because so many facilities were just doing this at the expense of their traditional process that they were very worried that this would kind of, change their industry. Now, 39 years later in Puerto Rico, Rafael Arroyo realized that there was an alternative to doing both of these, and figured out a way to make a standardized heavy rum fermentation driven process. Now, the one thing here when I say treated molasses that I have to talk about is he treated his molasses prior to fermentation in a very specific way. And if you find his book, Studies on Rum, it was released in 1945, you can read all about it there. And again, I'm happy to share. I can show you where you can find that online. But his process forced the precipitation of any of the impurities that were present in the molasses, and then it added necessary nutrients like phosphorus and nitrogen. Additionally, it liberated many of the desired acids into the molasses, which made it easier for these to be uptaked and utilized by the yeast and bacteria during fermentation, and thus ensured that the wash would be rich in acid and ester precursors. And as you can see here, it's quite a complicated process that he went to do this. Most importantly, he used Bombay, and his chosen strain was Clostridium saccharobactericum. And if you look at that process step, he was able to then make this on demand. So again, he figured out a way to make heavy rums without having to sacrifice any of the tank space available in there. And he was doing it in Puerto Rico, through the 40s and 50s. And honestly, many contemporary distilleries, for us nowadays, have explored this method at some point. Some of those, like Black Frost Distilling in Minnesota, they do a high pH, because the higher the pH, the more bacterial action that you're going to get. But you need to propagate a yeast to be able to handle that. So you've got a yeast that's ready to go, and it can go into that bacterial-rich environment. But if you read Studies on Rum, you'll be fascinated by what you learn. And again, this is why I advocate for so much openness in this industry, because after Arroyo's paper, you don't really see anything up until about the 90s. So we all need to talk about what we're doing so we can all make better rum together. And now I'm going to pass it over to John.
Hello again. So I'm going to talk a little bit about the application of all of the historical methods that Brett described, particularly from what we've done at Cotton and Reed and just the various experiments that we've tried. In general, at Cotton and Reed, we are very open to experimentation, with the caveat that it doesn't affect our core mark. And that is something that I'll definitely talk about in my first point, talking about dunder usage at Cotton and Reed. So previously here at Cotton and Reed, we incorporated dunder into our regular production. That was after we kind of studied a little bit about how it would interact, what it was going to do, and how a small amount of dunder usage would actually impact the final spirit. We determined that it wasn't going to necessarily be so significant, and the potential savings, both in water and energy savings, could have actually been very beneficial for us. So we did use dunder for about 1 year. The rationale behind this being water savings, it accounted for about 20% of our wash volume. So we were automatically saving 20% of the water that we had to use. We saw tremendous energy savings because we were using a relatively clean or sterile wash or a sterile dunder. And we maintained that in our still overnight after our previous stripping runs. So we just carried that dunder, reheated it back up to approximately a pasteurization point so it would be clean and ready to use. And that saved us a lot of time and energy input for heating up our wash and getting it ready to set. And we also saw an amount of chemical savings, and this is probably what most people would recommend the use of dunder or sour mashing for. Whenever we're setting our wash, we're aiming to set a wash at a target pH of less than 5.5 to kind of stave off bacterial contamination. And most of the time we'll do that with citric acid additions. The dunder allowed us to bypass that step and gave us a very nice stable addition of acid that put us kind of in a target range for fermentation in the upper 4s and low 5s, depending on how many times we'd recycled the dunder. Now, for downsides, which ultimately led to us discontinuing the use, we did notice there was an increased concentration of the non-fermentable. So kind of as Brett was describing, the more you use dunder, the more all of those solids that you recycle from your washes are going to build up. And that's going to lead to increased osmotic stress and then decreased overall yields. And it'll decrease the ability to decrease the amount of molasses and decrease the amount of sugar that you're able to put into your fermentation because you don't want to stress out your yeasts with exceedingly high osmotic pressure. So we were getting lower fermentation yields. If we set normally around 21 bricks, we have a pretty high fermentation. We normally can get down to 1 or 2 bricks. We were seeing our fermentations finish out and attenuate to 3 or 4 bricks, very similar to what Brett was saying. And that was hurting our overall fermentation yield, which then as we pushed that further into rectification, we were only able to get smaller and smaller amounts of alcohol. Furthermore, consecutive production weeks, recycling that same dunder gave reduced spirit yield because of the increase of the fusel oil concentrations. So if we were able to get, call it 280 to 300 proof gallons in rectification, we gradually had to pull that back all the way down to sometimes 230 for a significant loss because so much of the higher alcohols that were uncharacteristic of the rum that we produce at Cotton and Reed, they were just carrying over into the final spirit. So we eventually terminated our dunder program on the full scale after about a year due to a noticeable quality drift that was pointed out to us by one of our former distillers as he came back to visit and said, this is kind of shifted in quality from what you were already producing. For other modern implementations, part of my research project and the primary focus of my research project is targeting high-ester fermentations with commercially available Schizosaccharomyces pombe. That is a new product that's available on the market. And Brett and I were both working together to figure out how can we unlock high-ester fermentations for craft distillers so that everybody can produce much better, much more exciting rums. So what I'm intentionally trying to do is develop a scalable framework for small and medium producers to incorporate dunder and cane acid as the 2 primary adjuncts in their complex fermentations with Schizosaccharomyces pombe. I've also done very preliminary investigations in creating my own muck pit or muck bucket, as you'll see later. We'll talk about what the results have been there. And then I've also done experimental trials with both the Arroyo method and the Cousins process. And I will discuss that as well. So the first thing, which is really kind of a major thing that I'm doing at Cotton and Reed and that we're doing is pursuing cane acid. Unlike what Brett was describing, where cane acid is primarily produced from cane juice, we don't have readily available access to cane juice in Washington, D.C. But the origins of our interest in cane acid kind of started several years ago, as you can see in this picture, around 2022. We were experimenting with dunder at that same time and wanted to increase our total organic acid concentration as we were going into our still. As we started studying some of these historical texts, in particular Cousins and Arroyo, we started noticing that cane acid was a thing that was being used quite frequently to increase those organic acid concentrations. So we wanted to see what we could do to produce cane acid in a method that was attainable for us. The first thing we did was to actually try to make it with cane juice. We don't have a whole lot available to us, but we're lucky enough to be in a manufacturing district where there's a local wholesaler who brings in a certain amount of sugarcane, and we were able to get that, juice it, and allow that to naturally convert into sugarcane vinegar. It worked really well, admittedly at a pretty slow pace. The wild fermentation took several weeks to ferment just to alcohol, and then we kind of forgot about it for a long amount of time until the juice itself turned into cane vinegar. But of course, we wanted something that was going to be scalable and reproducible. So we sort of re-envisioned what does it mean to have cane acid. So what does a sugarcane derivative look like? Much like, rum can be made from anything that comes from sugarcane. Why can't cane acid? So we started experimenting with a molasses-based vinegar using our standard molasses that we use in all of our fermentations. We found in just our very rudimentary background research that vinegar can be produced actually from a kombucha SCOBY. So we took a small amount of a molasses-based wash and just added a kombucha SCOBY to it to see what it would do. Very, very slowly on a 1 gallon scale, it did wind up converting all of the molasses wash into vinegar. And we tried to scale it up into from 1 gallon up to about 30 gallons. And then we forgot about it for a couple of years, which lo and behold worked to our benefit, but we thought the project was dead. We thought the batch of vinegar was dead. But in the background, it was very slowly transforming. And while I was interested in highly acidic fermentations, I began looking for a yeast supplier that could provide something that could tolerate the really acidic environments that would be present if we started using dunder and cane acid in our ferments. Couldn't really find anything at the time, and it especially didn't work very well with traditional Saccharomyces, so we kind of let the idea go for a while. Jump forward to about 2024, 2025. My curiosity peaked again, and Brett approached me with a project idea with this new Schizosaccharomyces strain that was becoming available. He had been approached to use it and to see what he could do to produce high-ester rums. He knew I was really interested in high acid and using cane acid in my fermentations. So we revived the vinegar program. I went through and I tested all of the vinegars that I had just laying around that I had forgotten about for a long time. And I was very pleasantly surprised to find that they were up at 4 or 5% acidity, which, if you're familiar, is kind of exactly where you are if you're looking for commercial vinegar. So I started using that in my research project. And over the past year, as I've propagated a little bit more, I've increased the amount of cane acid that I have. If you see, and how it's going on the left image is about 50 gallons of cane vinegar that I had that I tested the other day that is sitting right around 5%. I split off some of that so that I could continue growing that up. And then if you look in the white bucket, that is what also looks like molasses vinegar, but that is actually distilled vinegar. So distilled vinegar being produced from a spirit, that is rum-based vinegar. We have a very neutral rum that we're able to use, and I found that if you dilute that to a really low ABV, something 7-8%, it can produce vinegar at a very, very fast rate. So some of the lessons that I've learned in producing cane acid and cane vinegar, I'm using what's called the surface method. So In the two pictures that you can see on the how it's going side, you can see, particularly in the left one, there is a pellicle across the top. That is essentially a vinegar mother or a SCOBY that is sitting on top, protecting the interface between the bacteria and the air, allowing oxygen to convert all of the alcohol into acid. It's a very slow process. Thankfully, it's very stable. As I forgot about it several times, it has continued without my attention. And it does develop a pretty rich flavor compared to some other methods, which I'm going to describe in just a minute. Kind of the downside, and maybe this is the downside of vinegar production and cane acid production, or whatever sort of acid production you would want to incorporate. It does require a certain amount of attention. For my acids using the surface method, I'm able to pay attention to it every couple of months or up to a year and figure out what it's doing. But if you let it go for too long, like for instance in that rum acid bucket, it eventually starts degrading itself, so it'll build up to a peak of acid, and then it'll start destroying that acid to produce more biomass. Ultimately, these bacteria and yeast want to produce food, so they'll start eating up all of the vinegar that you've worked really hard or worked somewhat hard to produce. So as far as other vinegar making processes go, one that is also very commonly seen is called the generator process. For this, you're basically creating an enclosed vessel where your bacteria are living and they're not actually living in the liquid. So where the surface method, all the bacteria are either suspended in the liquid or sitting right on top, the generator process has its own container that contains all of the bacteria. And you feed the alcohol down through that container where it's exposed to fresh air and oxygen, and those bacteria convert it on the surface of whatever your packing material is. Common packing material of your container will be like beechwood shavings or grapevines, very traditional methods that you'll see for wine vinegar productions and those sorts of things. An example, as I've kind of depicted here, is the Schutzenbach process, where we've got a column or a barrel, as shown in this orange picture here, that is filled with inoculated beechwood shavings. The alcohol disperses through the top and allowed to trickle down those shavings. And this is actually something that I learned that was really interesting. As the bacteria convert the alcohol into acetic acid, it produces heat. Heat naturally rises and forms the exhaust air. As that exhaust air goes out, more fresh air is drawn in, and that keeps the steady flow of oxygen going to those bacteria so that they convert. The benefit of the generator process, particularly over the surface process, is that it will produce a lot faster generally, whereas the surface process takes months to years to produce vinegar. A generator process can produce within a couple of weeks to maybe a few months. The monitoring here does require more regular monitoring than the surface process, but it does take a shorter amount of time. And this, compared to both the surface and the next process, which I'll describe, is most likely to exhibit stability without having to pasteurize the vinegar or without having to kill off your bacteria cultures that you've worked really hard to grow up. The most common method, and this is what's used in commercial vinegar production, is called the submerged process. In this process, the bacteria colonies are fully suspended in the liquid that you're trying to convert. Oxygen or air is pumped into the bottom, and so you are providing all of the bacteria with the air that they need in the solution, so they're able to produce very rapidly without any sort of transfer of the liquid that you're trying to ferment. The big downside here is as you bubble air or oxygen through the solution, you do wind up losing a portion of your volatile acids, your ethanol and your acetic acid here as well. But this is the fastest way of doing it. And it does also require more constant monitoring just to make sure that you don't let your alcohol go below that 0.3% threshold. You want to be regularly removing the vinegar that you've produced and replacing it with fresh alcohol so that you can keep producing. It is a continuous process, but also because the bacteria live in the liquid itself, you do need to either filter it or pasteurize it so that you can get clarity and also you can get stability. So as I mentioned, I've done a lot of work with dunder and in a lot of different forms. We've used dunder at Cotton and Reed. So kind of to describe the different production methods and different uses of dunder that I've worked with. The first is clean or sterile dunder. This is very much what Brett and I were doing with our Palm Bay research. We were taking fresh dunder from a stripping run, pasteurizing it, homogenizing it, and using it to set our next wash. The benefit there is, of course, that you're getting the organic acids that you've already produced recycled into the process, but you're not necessarily getting the benefit of the bacterial contamination or the bacterial addition that you would get if the dunder were allowed to form its own bacterial colonies. Here, the bacterial influence is going to be limited to the period between when the dunder is produced, so at the end of your stripping run, and when you set your next wash, whenever it's pasteurized or sterilized. That kind of transitions into dunder recycling, which is what I was doing back in 2021 and 2022. We were using the same dunder from sequential runs and recycling it in approximately the same volume for hours. And so we were getting even more organic acid buildup between fermentation and between distillation. And kind of as I mentioned, and why we discontinued the use of dunder is that with the increasing concentrations of the acids, we also got increasing concentrations of solids and osmotic stressors. This method does provide the greatest likelihood of contributing funk without having to actually incorporate a bacterial component or a bacterial co-fermentation. So kind of the big warning here, if you're choosing to recycle your dunder, is that if you have a garbage fermentation going in, you're going to get an even stronger garbage fermentation coming out. All of the bad fermentation products that you would be leaving in your dunder are going to be recycled and are going to grow until it throws your product way out of spec. So moving beyond clean and sterile dunder and the recycling of that clean and sterile dunder, you can use dunder as a bacterial inoculant. So dunder will naturally harbor bacteria, or it will take in bacteria that can start to grow either by intention or by accident. It's just going to happen. Dunder left under the right conditions, so warm and then a relatively moderate pH, not too low, will establish a bacterial infection just from ambient bacteria in the air or on the surfaces. As you can see in the image of the orange bucket, that is a bacterial infection growing in some dunder that I had that was high acid, and that looks to be lactobacillus culture that is growing there and ripening that dunder. So the bacteria are going to contribute their own organic acids. So in the case of lacto, it's going to contribute that lactic acid that whenever you go to use the dunder, you can either choose to use the dunder as a bacterial co-pitch, so either warm it up slightly or don't warm it up at all and just use it as kind of an ingredient. And that's going to provide a steady or a heavy dose of bacteria into your fermentation. Or you can choose to take that dunder that is now rich in the bacterial co-products, sterilize that, and use that as kind of an acid jumpstart. A big key consideration, I think, for the use of dunder, especially if you want to drive it more towards the direction of a bacterial fermentation, is that dunder is usually very acidic. You can often see it in the pHs down in the 3s and low 4s. And that low pH will actually stave off a bacterial contamination and instead is going to rapidly grow mold. Maybe mold is something you're okay with. Generally, mold is something that we would try to avoid because of the various harmful byproducts of mold infection. So if you do want to drive your dunder program towards bacterial infection, something that I could maybe recommend is raising the pH slightly and maintaining a higher temperature to direct bacterial fermentation. You want to get the pH kind of at least above 4.5, if not above 5, 5.5, depending on what type of bacteria you want to grow there. So as I mentioned, I have done early investigations into my own muck bucket. And this is very loosely based off of just what literature shows and what we have access to. As you can see in the background of this image is what the muck bucket looks like. I've created on a 5-gallon scale that, just to say, I haven't used yet. But in order to create this, I used the following ingredients. I had 2 black bananas. Black bananas, peel and all, because I wanted to have maximum sugar concentration contributed from the bananas so that the bacteria would be able to eat that. But also the bacteria that are natively living on the skins of bananas can help inoculate that wash. I did add yeast nutrients in the same sort of concentrations that I do for my regular fermentations, just to promote the growth of yeasts and bacteria. Molasses as a bit of a sugar source, not very much. I just used 1 quart for the bucket itself. And then I used high acid dunder to set the wash itself, or to set the muck bucket itself. The process that I use is very straightforward. I peeled and mashed the black bananas, all of it in the bottom of the bucket, leaving the peels, leaving everything in. I added the molasses and the nutrients to that. And then I diluted to the 5 gallons that I wanted with the high acid dunder. At this point, I knew it was going to be important to get the pH to a level where the bacteria would be able to colonize and thrive. So I adjusted the pH from very, very low, because it was a high acid dunder. It was probably about 4.3 or something like that, up to 5.5 with calcium hydroxide and calcium carbonate. Kind of warnings for both of those. Calcium carbonate will produce a lot of CO2 as it reacts. So I did overflow this bucket a few times in adding calcium carbonate to get my pH up. That's when I switched to calcium hydroxide. It is a more powerful base, so a little bit goes a long way, and it is a little bit stronger to work with. From there, I checked the pH daily, and fermentation started within about 3 days or so, and I maintained the pH above 5.0 for a week until it naturally stabilized. And even now it's still sitting about 5.3. Again, I haven't used any of this in my experiments. The pit appears dormant, as you can kind of see in the picture, but I should be getting within the ideal time frame of a very ripe muck pit within that 3 to 6 plus months range, so that it is going to add a lot of the esters and a lot of those organic acids that the bacteria have been producing. Since I know everybody is probably curious, what does it smell like? It does smell pretty awful. It smells a lot like rot, garbage, and of course, old bananas, moldy bananas, and tails. Tails probably mostly coming from the dunder itself. How do I keep everybody from being upset with me? Well, so the bucket is kept sealed. The process of producing muck is an anaerobic process. You want the bacteria at the bottom to do everything. So I keep it sealed. It builds up a nice CO2 layer across the top. And then I take that sealed bucket and I keep it in a fermentation bag with a heater attached to it so that it maintains a desirable temperature range for that. I will say, taking this picture that I've used in the background here was the longest I've ever had the cover off of this bucket. And it was probably 5 minutes that I had it on, and the aroma took over the entire distillery for at least half the day. So every time I would walk in, it would smell like bananas and trash. It's not pleasant, but it is doable if you want to do that and you are careful to keep it all nice and sealed up. So to kind of go over what I've described and how it blends with the work that Brett described, a modern high-ester fermentation process would kind of look like the following. We would take cane acid at 5% or so, dunder, for whatever percentage of your wash you want, whether it's 5%, 20%, something like that. molasses to set to your target bricks, and water. Set that, form a regular rum wash as you would normally without the presence of cane acid or dunder. Hit your yeast. In this case, we're using Schizosaccharomyces pombe because it is resistant to all of the acids that we're putting in. And then the rum will proceed in fermentation either with or without bacterial influence, depending on whether or not you sterilized, pasteurized your cane acid and dunder. At the end of alcoholic fermentation, you can add your muck, which is what I would be doing, and then allow it to go for a secondary fermentation in which the bacteria are going to begin breaking down all of those precursors and making even more to really, really add that funk to it. So I did mention that I have also done the Cousins process and the Arroyo process. For the Cousins process, it is very chemically intensive. The chemistry here, kind of to do a summary, so you take all of the organic acids that are in your lees, so the mostly water, very low alcohol that is left in your pot after a rectification. You take all of the organic acids in there, you treat that with a base. In my case, I was using calcium carbonate and calcium hydroxide. That base is going to react with those acids and form an insoluble salt. And the salt is really what you want to collect. After that, you need to take the liquid and concentrate it off. So you just evaporate the water, filter the solids, and then you take those solids, which are all of your organic acid salts, and you add those to, I did tails. It can be really any kind of distillate, but you're going to want something that's going to have higher alcohol to have more interesting esters formed. You'll treat that liquid or that suspension with sulfuric acid. The sulfuric acid addition is going to form a different salt, so you'll precipitate out calcium sulfate, and then you have to remove that and take the liquid that remains after that second filtration, add it to your still charge, and then redistill it. I did this the other day just to see what the process is like, what are the benefits, what are the shortcomings. Let's see. And I did an in-house ester titration, which is something that I've been incorporating more as I've gone through my research project. I did titrate the esters and find that it is approximately the same in ester concentration as a clean Pombe distillation versus the Cousins process, but you can definitely tell that it is different. The organoleptic qualities, the aroma, the mouthfeel are all very distinct from what is a clean rum or a common clean. I have some ideas about why that happened. If you would like to talk about that more, feel free to reach out. So what if you want to do the Cousins method yourself? What are some key considerations? First and foremost, and this is why I think the Cousins process is not largely more utilized, it's a very inefficient process. It requires a very significant amount of chemicals to get relatively low yields. So in the 4 liters that I took out of my distillation, I recovered about 1.7 grams of organic acid salts back. And some of that might have actually just been salts, might have been leftover calcium carbonate, calcium hydroxide. You have to evaporate all of that water, which takes so much time, so much energy. I was just doing it on a hot plate, and even 4 liters took 4 to 6 hours without trying to just send it really hard and scorch a lot of those really hard to isolate and hard to get acids. Also, very importantly, the process itself is relatively hazardous. It requires the use of very strong acid. Sulfuric acid will burn you. It will burn your clothes. It will eat holes in pretty much anything that it touches. If you're going to try this process, you should definitely make sure you're doing slow additions and wear proper protective equipment. Additionally, the strong acid may damage your equipment. It will start pitting stainless steel. It will definitely damage your copper. So make sure if you're doing this process, do it in glass or plastic. And whenever you go to charge your still, make sure it's neutralized and at a more reasonable pH. My recommendation, if you want to try the Cousins process, don't shy away from it if you're truly interested. I shied away from it for years, but I do recommend trying it on a lab scale first. You will see how difficult the process is, and you can evaluate for yourself if it's worth it. Ideally, the Cousins process is recommended to give you a concentration of organic acid salts from 4 or more runs. And of course, if you're evaporating all of that water, getting all of those salts isolated is going to take a very long time, be very, very energy intensive. But you definitely can see the benefit of recovering those salts and reintroducing them into your distillation. Make sure you have the proper equipment to monitor and test your pH. I can't recommend any more highly doing titrations of all of these processes. If you're not familiar with how to titrate, learn how to do that before you attempt the Cousins process or even the Arroyo process if you want to do it very strictly scientifically. Your fermentation, you want to optimize for higher alcohols, higher organic acids, just to make sure that whatever you recover at the end is going to be high enough concentration. And then, as I mentioned earlier, perform your mixing in plastic or glass and readjust your pH at the end to make sure you are protecting your. For the Arroyo style fermentation, this was a side experiment that I did during part of my larger trials with the Palm-Bay strain that I've been working on. So I applied the Arroyo method to my trial size fermentation, which is 23 liters. One of the key benefits of using Schizosaccharomyces Palm-Bay is that it is incredibly stress tolerant and is the strain that is most commonly referred to and recommended for doing Arroyo style fermentations. So I wanted to test the limits of this commercial strain to see if it could withstand it, and also co-ferment with the bacteria that are produced in the Arroyo style fermentation. So I set the wash for this fermentation according to my optimized procedures. Just as I'd be glad to provide the full details of that. If anybody wants them, please reach out. But as kind of a quick briefing, it's a 2-day nutrition supplementation, a high pitch rate, so 1 gram per liter, and then temperature control regulated at about 90 degrees Fahrenheit. This was set with a high acid dunder, using 40% dunder, 40% by volume dunder in the 23 liter fermentation. And I, for about a week, worked to maintain the pH above 5.8. And that did allow for bacterial co-fermentation. I will say after every time I added base to the ferment, it did stall out the alcoholic fermentation. But that is one of the benefits and the downsides of the Arroyo style fermentation, is that it does go slower. As you add the calcium hydroxide or calcium carbonate, whatever you choose, to raise your pH, you will also, in the same way as the Cousins method, produce organic acid salts. In my experiment, what I wanted to do was also liberate those organic acid salts, so I treated that with sulfuric acid as well. And kind of the big takeaway, this is a diagram that I presented recently in Scotland, just discussing my research. If a baseline clean Palm-Bay fermentation gives 60 grams per hectoliter absolute, and as just a basic ester count, the Arroyo method far outperformed literally every other trial that I did, and it gave almost 300% of that baseline fermentation. So it is a very effective method at producing high esters and high acids. A few considerations for the Arroyo method, and a lot of this is stuff that Brett discussed already. You are sacrificing your alcohol yield for flavor. So I would always set my washes at about 22 bricks, somewhere pretty high again. And even this case, it stalled out to about 10 bricks. I was optimizing for 11% alcohol. I only achieved about 7%. But as you saw, the 7% was much higher esters than any of the previous fermentations and distillations that I had done. There is a chemical requirement calcium carbonate or calcium hydroxide or whatever base you would choose to keep that pH up. And you want to be able to test that pH. You want to have your pH probes, pH meters, whatever. And you do have the option, much similar to the Cousins process, to liberate those organic acids at the end, which again is potentially damaging to your equipment, but it does provide a lot more of the organic acids into solution. And last, and probably most important, this is a requisite bacterial co-fermentation. The bacteria, if you're keeping that pH up, it is going to take over, and you will need to up your sanitation protocol for reusing your tanks or whatever, unless you're going to maintain doing the arroyo process for your fermentations in that tank from then on. I believe now I will pass it back to Brett to finish up.
All right. Yeah, so what we covered today has been nearly entirely rum focused because that is where it originated from, and that is what's driving a lot of the excitement behind attending this, as well as the current research efforts going on within the rum industry. But there are significant applications outside of our category, specifically for whiskey and brandy. John and I recently presented at a conference in Scotland, and after giving my talk, people approached me with questions about whiskey and brandy production, specifically high-ester, which prompted this slide. So it's mainly because you see differentiation opportunities. You don't really hear people talk about high-ester whiskey, but all the components are there. Like you can make grain acid, right, which is just malt vinegar. You already have sour mash, which is dunder, and the muck. A grain-based muck would be its own challenge, but it is something that can be done. And then the similar analogs for brandy could also be done. Lab and pilot plants will be key to success. So just like John showed pictures of, you want to do this in the lab, see if it works, and then if it does, figure out how to scale that for your process. And university programs, as well as research institutes like the Beam Institute, Scotch Whisky Research Institute, and others can take the lead. So for a smaller brand, for example, this is could be a key innovation and also be used as a blending tool. Just for the sake of this, I have created an example high-ester whiskey fermentation. So you'd have your standard mash, you mill your grain with water, mash in, and then at that point, you can choose to add your grain acid and or backset. So these would be used as dilution targets. But again, depending on what you're mashing, you'd have to do it at the temperature profile, so you may end up just killing all the bacteria and getting their acids, or you can add them later, post-cooling, before you add your yeast, to finally dilute to your target gravity and then yield a mash that is rich in bacteria as well. And then just like John showed before, you would then add your grain-based muck for a secondary fermentation before distillation. This is something that is entirely doable for whiskey and or brandy producers, and in fact, you already have 2 facilities in the U.S. that are currently experimenting with this. On the left is, on the far left image is Leopold Brothers in Colorado. Todd Leopold has been experimenting with like a dunder or muck pit, all grain-based. And with his recent malt vinegar program that he's done, he is now well on his way to making what he calls blender barrels by leveraging these techniques. The 2 other images to the right are from, again, Black Frost, who exclusively uses Schistosaccharomyces pombe for their whiskey as well as their rum program. And by leveraging the pombe's ability to handle like higher acid, more challenging fermentation conditions, they're able to do on-grain, non-stale fermentations and yield very rich, beautiful whiskeys. And again, so these are people that are currently doing this, and it is definitely worth exploring for category innovation. As a case in point, based on my presentation I just recently gave, every country in green would allow this. So it is a big opportunity depending on where you are in the world. Only reason, for example, India is in red is because they have an upper bounds, and then for ester concentration. And the only reason the United Kingdom, Ireland, and Japan are in blue is it really depends on how you interpret their regulations. So if you're interested in this, feel free to reach out. I'm happy to chat with you further. But it's an exciting time to show that rum techniques can be, utilized to drive innovation in other categories, because it is coming, I promise you. As a wrap up, and John, feel free to hop on. We can both discuss this if we want. But we've covered Jamaican methods, the Cousins process, the Arroyo method, and modern applications. So we have shown you means of producing high-ester rums by utilizing fermentation adjuncts, so dunder, cane acid, and muck. John has thoroughly covered the Cousins process, the process with cautionary tales, and shown how it can enable the development of high-ester rum production without complex fermentations, but it does require a lot of energy. And the Arroyo method is using your fermentation progress toward bacterial co-fermentation, and then leveraging that to get your heavy rums. And then John beautifully covered all the modern applications. And John, if you have anything else you'd like to add?
I don't think there's really a whole lot I'd like to add, but I will say, if you're interested in these methods, give them a try. Don't be afraid. Just be wise. They're a lot of fun. They've existed for however long, just hiding in the history texts. And I do think there is a lot of potential to revive these, to modernize these, and do really, really cool and creative stuff.
I second that, and especially with the resurgence of long lost stills like the 3-chamber, it really opens up the opportunities for a lot of cool stuff. Not only in the rum industry but in other categories as well. Well, with that, this is how you find us in our respective brands and companies. So please do reach out, whether that's on LinkedIn, Instagram, or email. We'd be happy to field your questions and continue the conversation. And again, highly recommend openness in this industry, because that's how all of us are going to be able to make better rum.
Thank you, Brett and John. We do have a question here from Mateo. If anybody else has any questions, please drop that in the Q&A on the public chat. For the method of distillation, what is your advice for the percent alcohol of the distillate using a still without retort?
Is that question, and feel free to comment in the public chat, is that question in regards to increasing the alcohol percentage of your distillate, or are you're talking about yield? I don't quite understand the question.
He also wrote here, when do we know when the dunder is ready to be used? What will be the process for heavy rum using only fresh sugar cane juice and without molasses? Just cane acid and dunder, and both to be added at the start of fermentation. Why sterilize it?
Okay, I think going back to the first question for method of distillation and percent alcohol of the distillate, as I understand the question, what percent ABV should you target to get most of the esters and the high alcohols over? I wanted to replicate something that would be similar to what we would use at Cotton and Reed. So we do have a relatively high distillation proof. Most of my research has been carried out getting distillates off around 82%, 81%. I know Jace typically will target at Black Frost. He'll come off much lower, as low as the 120s, 130s in proof. And it really is just going to depend on what your own preference and style is. The lower you go, you will start to distill over more of those higher alcohols, more of those esters, because they are very high boiling compounds. But again, depending on how late or how long you want to age this, or if you don't want to age it, that's going to influence what your cut should be, what your distillation proof should be.
Great, thanks. And do you want to take a stab at the second one? When do we know dunder's ready to be used? Why sterilize it?
So as far as my use has been, again, it really depends. It's the worst answer I can give you, but it depends on what you want. So dunder, if you want it just for the organic acids to be recycled that you already produced your first fermentation, you can use it right away. But if you want it to ripen and to develop all of those new organic acids from bacterial co-fermentation, you want to get that pH up a little bit, and you want to let it go until it forms that pellicle, until you can actually visualize the bacteria taking over that dunder. And then once you can see that, it's how long do you want to let it go? Do you want it, once you see it, you want to use it, or do you want to let it go for a couple weeks to develop as many of those acids as you can? Brett, do you have any thoughts on that?
Not really. I've only used fresh dunder mainly because we're limited with our tank capacity here. But I mean, I agree with what you said. I mean, that seems to be the easiest and most straightforward path of ensuring that you can either do it fresh, or you can have like an actual ripe dunder pit. Again, it's one of the things that you see in the literature that they don't. I mean, there's some discussion about what they did back in 1900, 1890s to 1920. How they were able to do this, but those techniques compared to now are quite rudimentary in the sense of what was available, and especially given that time in the Caribbean. But yeah, I would say what John said is probably the easiest way to do it. Just again, like he's the one kind of writing the book on this, so again, like I ask him questions to be fully transparent here. But I'll take a low-hanging question here from Brad. You can find Schizosaccharomyces pombe from AB Biotech or AB Mallory if you're in like Australia, Oceania. And I would definitely reach out to Alex Moriarty or Kevin Kawa as your points of contact. And if feel free to reach out to us. I'm happy to send an introductory email. But you can leverage its ability to handle these complex fermentations and these acid conditions because it will produce a very interesting rum. I mean, just comparing it to a standard Saccharomyces cerevisiae, like if you compare it to EC 1118, it's night and day different, just the standard fermentation. And then when you start adding in these other components, you're allowing it to really do its thing and yield a distillate that's beautiful.
We talked a lot about fermentation methods and pre-distillation. What type of stills do you use, and then method of distillation?
My experimental still, my stripping still is just a pot still. My rectification still for experimental bases is an eye still, which most closely approximates the hybrid type pot and column still that I use on my full scale. I would probably recommend, if you've got access to it, doing it on a pot still, because you'll get more of those compounds over, and you'll lose less to the rectification of a column. But Brett's got some ideas on how things could possibly be used for column distillation. I know Jace uses column distillation, so use what you've got first, and then if you need something else, look into it.
I mean, like
Instead
one of the.
Go
I was
ahead.
just going to say, like one of the things about the Cousins process again is like it definitely can be used, and one of the reasons that Cousins developed it is, like John talked about. He realized that all the acids are all concentrated in the retorts. So by leveraging that high-ester fermentation, it made sure that those acids were present in those retorts. And through successive iterations, by concentrating them, he was able to then do that. So, for example, if you're doing this and you wanted to do the Cousins and experimented with these higher ester fermentation techniques, you could do that over a series, of weeks, get enough of that material, and then undergo this energy-intensive step to liberate all those acids. And then, as John described, balance your pH, dose back in, and then see what happens. And if you do that, please do reach out to us, because we'd be very curious and would love to learn more about that. But then those types of things for a column, if you were to hypothetically just take it all the way through, you could figure out some kind of way of automatically dosing while you're doing that, say like in your doubler or your thumper. So as it comes over, you're dosing, You just would have to figure out the timing to do that, but you could figure out a way of doing that. And then if you were to do that, you could then effectively make high-ester rum on demand until you run out of your salts.
Instead of using a homemade cane acid vinegar, could you use commercial vinegar or lab grade acetic acid for similar effects?
Love this question because I agonized with these kinds of questions for a long time in developing my research proposal. So it really kind of depends on how you interpret the regulations of what constitutes a specific spirit category. So for me, making rum, it has to be something that is sugarcane based. So I wanted a vinegar that is sugarcane based. Does that mean I need to make it from molasses? Do I need to make it from sugarcane juice? Can I make it from rum? It's really kind of all up for interpretation at that point. For using commercial vinegar, a lot of that's going to be distilled vinegar. So how do you maybe feel about blending what is effectively soured vodka into your fermentation? If that matches how you interpret how you would interpret regulations, then by all means, go for it. Lab grade acetic acid, I would be very careful with because you're going to need to make sure that you get the percent acidity correct to not just kill everything. That stuff gets up to 12 to 30%, and that's just too much. Now, I will say personally, I would love to hit 15% acidity in a fermentation, but that's a personal goal, not necessarily a thing that I would do with a lab grade acetic acid.
Is there any use for a really old dunder pit over 1 year?
Brett, do you want to take that, or do you want me to take it?
I think you should take it. I was looking at Matthew's question about fresh juice, and I'm just coming up with an answer.
So, use for a really old dunder pit, it would depend if it's still alive. If you still see that it's got bacterial activity, sure, why not? Why not try? Or if it's to be cautionary about it, if it's growing mold over a year, you might want to be careful about that. Again, if you're okay with mold, you are risking transferring those mold spores and the various hazardous byproducts into your fermentation, into your distillation. They shouldn't distill over, but it's hard to say. But yeah, I think, if you're aging a dunder pit for that long, you might, depending on what bacteria you've got growing in there, you might be pushing into that muck territory. You might be looking at transforming it into an entirely different thing, which is cool and really exciting. You just have to determine, is that what you want it?
I only have access to fresh juice, no molasses. Heavy rum can still be achieved with just cane acid and dunder?
So I'll say this. So like in the work that I do in the Caribbean, in Dominica, when we do cane juice rum, we also do molasses as well, but it's primarily cane juice during the season. And especially if you look at any of the ester reports from any of these high ester, like the modern ones that you see now, most of the, I'd say 98% of the ester content is ethyl acetate, which, is just an ester from acetic acid, right? So you can absolutely make heavy rum from cane juice. And I mean, in fact, you've got so much stuff on the cane stalk as well. If you just kind of experiment with crushing your cane juice, throwing the cane stalks in there, letting it ferment, and just kind of documenting and checking what's happening during that, I don't see any reason why you couldn't do that. The only thing that muck really brings into the overall, say, equation is you're getting those butyrates and propionates and those types of heavier, like tropical fruit notes. But I mean, if you're doing anything with dunder and you're getting lactic acid, you're going to get ethyl lactate, you're going to get tropical citrus notes, you're going to get enhanced creaminess in the mouthfeel. And I don't see any reason why you couldn't do it. I mean, there's plenty of facilities. MOBA, for example, makes high-ester rum exclusively out of cane juice in South Africa. So there's absolutely, you can do it. And again, they'd be a great point of contact too, but it's definitely possible. Where are you based, Matthew? Just shoot me just let me know in the chat. and I might be able to help.
This one is, what is the easiest way to produce cane vinegar? I don't know if we really have time to go into that, but I mean, I'm sure you could search that. I don't know if you guys want to add to that at all, or
Easiest way I would recommend, depending on if you interpret it as cane vinegar, take a pretty neutral rum, bring it down to 6 to 8% alcohol by volume, and pitch acetobacter in it and some yeast nutrients. It'll take off. It'll actually go really quickly. If you want to go even faster, then aerate it. Pretty straightforward.
any plans to try double retorts? There's been a lot of discussion around these stills for being critical to the process we're discussing. Approach to loading the retorts are critical to create a reactive distillation approach where esters are created as Fischer esterification products. Do you need a double retort system to properly utilize all this is maybe the question there. I mean, I do know I've seen a bunch of distilleries in the US that do have a thumper or two thumpers on the back end, but yeah, what are your guys' thoughts on that?
I will say, actually, reading the contemporary discussion from the 1890s, 1920s, some of the facilities had two retorts, some only had one, and you could still leverage the acids that are concentrated in that to do that. And I mean, you're absolutely right. Having a double retort would help because then you'd have two stages for different acids that would come over, given your distillation length and your boiling points and all of those types of things. And John can feel free to hop in. But again, if you have a thumper or a doubler or just a secondary thing that you're going into, you can absolutely leverage these techniques. And then it's just probably going to be iterative to figuring out your dosing, your timing, exactly how to do this in a way that makes sense. Because like you said, there is a very specific way to load the retorts for your intention. So I don't see any reason why you couldn't do it if you only had one. But John, feel free to hop in.
I'm assuming you're trying to look at the Cousins process. If not, then that's fine. I would not necessarily say you need it. I'm doing all of these processes without any sort of single retort, any double retort. You will get greater esterification the more times you give it exposure to the acid. So there is a benefit to having those double retorts, but I don't necessarily think it's necessary.
Sorry. Could you use a friendlier acid than sulfuric acid for the Cousins process, like citric acid?
So yes and no. I have considered if you could use phosphoric acid, and I do think you could use phosphoric. It needs to be a really strong acid. Citric acid, I don't think is going to be strong enough. The benefit of sulfuric acid in particular is that you're going to precipitate out calcium sulfate. So the calcium salts that you have are going to exchange with the sulfate from the sulfuric acid, and that's going to become a solid. If you start using, friendlier acids, that's all going to stay in solution, and you might not actually get the esters that you want.
I had a question. So the butyric acid smells like rancid vomit. It's like the word, like in my organic chemistry lab in college, I spilled some on my skin and went to one of my classes afterwards, and everybody's like, "Oh my God, what's wrong in here?" And but during that process, we changed it into peach oil, or it's like it converts. When does that esterification happen? When does that conversion of the butyric acid happen? Is that caused by the heating in the still, or is it where does that actually? Or is it part of the fermentation process?
John, do you want to take this? You're the chemist.
Yeah, I can take it. So it's not part of the fermentation process in general. For the most part, it's going to either be in the still itself, where it's going to be combining with your ethanol, forming like ethyl butyrate and all of those sorts of butyrate esters. But for the portion that does actually come over, that butyric acid that does come over into your distillate, that's going to be one of those hard things that's going to take years in a barrel to occur naturally. And as you have organic acids contributed from the barrel itself and from whatever's in your distillate, that's going to drive more of the formation of those butyrate esters. So, if you have a distillate that smells kind of pukey, give it some time, and it might actually turn into all that nice stuff. But it's not going to be something that you want right off the bat. It is going to smell bad.
Well, thank you all. It's we're an hour and a half in, over an hour and a half in. It's amazing information. There's one more question here. We should probably, I'll just wrap it up. It's about aging techniques. But thank you all so much. It's such a pleasure. Jeff, if you want to reach out to these guys, their contact information is out there. And thank you so much.
Thank you, guys.
Thanks, guys.